Alright, welcome to my long-awaited DC20 math video. In fact, I'm not going to make one video on this, I'm probably going to start a new series. And this is the first video in that series. I'm going to start with some attack math. Now, really, attack math is a loose term for what I'm doing. There's a lot of scenarios that the math I'm using is going to apply, but largely it's going to be for attacks, finding out the average damage of an attack you're using. This is going to apply to both spells and weapon attacks, but I'm going to phrase things more as if they're weapon attacks because I think that's more intuitive. I'll get into a point later in the video where the line is going to be a little bit blurred. But let's start with some real basics. The D20. This is our foundational system for understanding how damage works in DC20. See, unlike games like D&D where you need to talk about a bunch of different dice because we're also talking about the average result of rolling damage dice, there are no damage dice in DC20. So all we have to think about is just the D20. So D20 is a 20-sided die, meaning there are 20 possible results we can get. Listed on the top, we have anything from 1 to 20. So let's imagine a scenario. What if I wanted to roll 20 specifically on the dice? How would I know how common that is? How likely am I to get 20 on the dice? Well, this should be a simple question as far as the math goes in this video. There are going to be 20 sides on the dice. There's one option I want. So that means 1 out of the 20 possible options is the one that we want. So we just do this as a fraction, which is in fact going to be some division. There's the amount of options we want, or I want, which is 1, the 20, and the amount of possible options, which is 20 different options. That means that on a 20-sided dice, we have 1 out of 20, or a 0.05, or a 5% chance to roll the d20. Now, I'm going to talk about percents here and there, but I want to make it clear that for doing the math, it's actually not convenient to use the percent number. There's a lot of reasons that are deeper that go into this, but to think about it simply, 0 represents not having any chance to do something at all, and 1 represents an entire chance of doing something. If I multiply something by 0, it's entirely gone, meaning it's not there. And if I multiply something by 1, it's maintained, meaning it's entirely present. So multiplying something by a number between 0 and 1 either gets it to be removed or have its full value. And that's what we want to represent. If I'm attacking you with a weapon and it's always going to do its full damage, that's 1 times the damage of the weapon. Or if I'm attacking you with a weapon and it never does damage, that's 0 times the damage of the weapon. Okay, let's talk about how rolls actually work in DC20. We need to roll something like a 10 or higher, right? And so oftentimes we have some number that we need to beat. We can call this a target number or the number we want. And oftentimes we're going to talk about this in the frame of beating a number. So let's say we need to beat a 10, right? Well, on the top I've shown all the numbers that are going to work. Anything from 10 to 20 is going to help us beat that 10. And remember in DC20, if I get exactly the number I'm looking for, then I beat that number. So there are 11 possible options that work here, everything from 10 to 20. If you don't believe me that there are 11 of them, you can go ahead and count them. For some people, this is a little bit counterintuitive, but that's why I put the numbers up on the screen. So there are 11 options out of 20 possible options. We can do the math. This is something you'd use a calculator for anyways. You do 11 out of 20, we get 0.55 or a 55% chance. Okay, so that means if I need to beat a 10, a DC 10 check, there's a 55% chance that I'll beat it, at least assuming I'm not adding anything to the roll. For some people, this can be a little bit unintuitive. They might think that since a DC 10 is right in the middle of rolling a D20, that it's going to have a 50% chance. This isn't true. In reality, an 11 is going to give you a 50% chance of succeeding because you can always get the exact number and beat it. Okay, let's make a generic formula for this. If I wanted to beat any number, let's say some number x, well then I could find out what my chance is by doing 21 minus x over 20. There's actually a couple ways I can write this equation, but this is probably my favorite, and it helps represent that, okay, if I needed to roll a 20, well that's 21 minus 20, so it's 1 over 20, which is the number we got at the beginning. And if I wanted to roll anything that's a 1 or higher, so basically if I just wanted to get a result on the dice, that would be 21 minus 1 over 20. So that's 20 over 20, which is just 1. It represents I'm always going to get some number on the dice, right? Unless they never stop rolling. Okay, so This is going to help us start to understand how we do the probability, right? It's going to be 21 minus the number we need to meet or beat, and then divide that by 20. Okay, let's talk about critical boundaries. See, in DC20, there is a little bit of a caveat to what you're rolling, because the 1 and 20 on a dice are somewhat sacred. Rolling a 1 will always lead to failure, and rolling a 20 will always be a success. So this 21 minus the number minus x over 20 has limits to it. We're actually never going to be able to get a value that's going to be lower than 0.05, and we're never going to be able to get a value higher than 0.95, right? The reason I have them lined up like this is because I'm always going to be able to roll a 1, so it's impossible for me to actually get a 100% chance to succeed any check. The best I can get is a 95% chance. There's always that 5% chance I roll a 1 and fail. Meanwhile, I'm never going to get a 0% chance of success. There's always going to be some slim chance that I can roll a 20, that 5% chance. And so we have to keep in mind as we put in numbers into this equation that there is a little bit of a limit here, right? I actually am never going to get a value lower than 5% and greater than 95%. Okay, let's talk about this in a more relevant scenario, the attack context. So let's work with a basic assumption before we start playing around with some variables. Let's say I have a +4 attack check and I'm trying to hit something with a 12 PD. This is a pretty standard arrangement of numbers to be used when we're guessing how common we are to make an attack. 12 is a pretty average value for PD. So the number we need to meet or beat here is going to be determined by the attack check and the PD. In this case, intuitively, you might realize that I need an 8 to hit. And in fact, we can figure that out by taking the PD and then subtracting from that the attack check. So in this case, we have 12 from the PD minus 4 for the attack check. That gives us 8. And that is, in fact, the number we need to succeed. We can see it here. I've highlighted every single number that works from 8 to 20. So we do 21 minus 8, and that's going to give us a 13 over 20, or a 0.65, 65% chance, right? So that's going to let us know how often we're going to hit an attack if I have a +4 to hit and you're hitting an enemy with a 12 PD. Okay, this is starting to get us thinking a little bit about how we can use this math for attacks. So let's generalize this a bit. Let's just say I have some attack check with some value A, and I'm trying to hit something with a defense of D, right? This could be the A would be 4 from before, and the D would be the 12 from before. So I have that 21 minus x over 20. And what is x in this case? X is always going to be our defense minus our attack. So we can kind of swap that out where we have x there in the equation. We're going to instead put in the defense minus the attack. And you'll see I have this in parentheses because it's this whole value we get at the end of defense minus attack that matters for us. So with a little bit of arithmetic, we can rearrange this. And instead of saying 21 minus d minus a in parentheses, let's just make that say 21 plus a minus d. Looks a little bit cleaner, and it's the same sort of meaning, the same math. Okay, so now we have a little bit of a more interesting scenario where we can describe any situation of a mix of some attack check and some defense, right? 21 plus the attack check minus the defense over 20. And that's going to tell us the chance that we're going to hit that target. So here it is, laid out a little bit cleaner, right? Our hit chance is going to be 21 plus the attack minus the defense over 20. All right, let's talk about heavy hits now. See, in DC20, you don't just hit a target. If you hit them really hard, you get bonuses for that. So on the top here, I have the numbers that'll let you hit, and that's going to be that same 8 through 20, right? But if you want to get a heavy hit, you'll need to get anything from a 13 to 20. You need to go 5 above their defense, right? In this case, that would be as if you were trying to hit a target with a PD of 17. It's really intuitive to think about heavy hits and brutal hits as trying to hit something that has a PD or a defense in general that is 5 higher than the number you're starting out with. In fact, you can notice here that there are 5 values missing from the top row of numbers compared to the bottom. Those numbers from 8 to 12 are gone, and they won't work for a heavy hit. They're just going to give me a regular hit. So we can kind of do the same maths before, looking at this and putting in those attack and defense numbers. So we can say, okay, well, this means it's really like saying 21 plus the attack minus the defense plus 5, right? Our defense is just bigger by 5. Well, we can do a little bit of arithmetic right here and rearrange it. So we can say it's really like saying 21 minus 5 plus the attack minus the defense. And because we can kind of combine 21 and 5 and negative 5, or we can take 21 minus 5, we can really just say that the heavy chance is going to be 16 plus the attack minus the defense. We can continue this logic for brutal hits, right? Brutal hits are also going to be 5 harder to hit than a heavy hit, or 10 harder to hit than a normal hit. And so here we're going to see there's only 3 values that are going to let me get a brutal hit in the scenario where I have a +4 to hit against a 12 PD. Only 18, 19, and 20 will count as a brutal hit. And so, same as before, we can talk about a brutal chance. Here's my generic brutal chances. It's going to be 21 plus the attack minus the defense plus 10. And same thing as before, same type of rearranging, we're going to end up with 11 plus the attack minus the defense. Now, if we wanted to, we could keep extending this logic for higher levels of brutal hits. In fact, you've noticed that it starts with 21, it goes down to 16, it then goes down to 11, and then the next one would go down to 6, and it would get harder and harder to successfully get higher levels of brutal hits. Most of the time, you're not going to get more than a brutal hit on a target unless you're getting large bonuses to your attack checks, or if the defense of the target is very low. Okay. Here it is, summed up neatly for all 3 of these chances. And you can see that they kind of scale down, right? The only difference between our hit chance, our heavy hit chance, and our brutal chance is that number at the start, that 21, 16, 11. We can just keep reducing that number by 5 to find out what that next level of brutal is going to be. Okay, so let's put some of this together to some good use. Let's talk about calculating damage. This is what people really want to know when they're doing their attack math. They want to know how good their weapon is. And I'm going to talk about a weapon. A lot of the same logic here applies to spells, so keep that in mind. So let's use this same example from before, a +4 attack check and a 12 PD. And in this case, let's talk about the damage. We'll use a nice and simple 1 base damage weapon. So here on the bottom, I've shown with some red and green when you would miss and hit. So on a 1 through a 7, it would be a miss and you would deal 0 damage. And from an 8 to a 20, it would be a hit and you would deal 1 damage. So if we wanted to calculate that damage, then we just multiply that number we need to meet or beat it, right? That attack chance, that hit chance, to the damage we'd be dealing when that happens. And in fact, we're going to see that in this case, the average damage just comes out to be the same as our chance to hit because, well, we have a 1 times the damage is just a 1. So when it multiplies out, it's the same number. Except that's not really the average damage of a 1 base damage weapon, because we've already talked about some complication here. In DC20, we have heavy hits and brutal hits, and even critical hits. So our damage isn't just 0 or 1, it goes on a sliding scale. On the bottom here, I actually have what the damage would look like. From a 0 to a 7, we would deal 0 damage. From an 8 to a 12, we would only deal 1 damage. From a 13 to a 17, we would deal 2 damage. And an 18 and a 19 would deal 3 damage, but a 20 would deal 5 damage, right? Critical hits in DC20 do 2 more damage. So this is actually what the damage would look like. It's a little bit more complicated than just 0 or 1. So this is where we can kind of get into the weeds. Let's talk about how this gets a little bit more complicated by looking at each of these different categories. So a heavy hit is what we just talked about, right? It's 21 minus the number we need to meet or beat, which in this case is 8, over 20. And we multiply that by 1 because that's the damage of our weapon here. A heavy hit is going to be the same thing. It's 1 times, this heavy hit chance, 16 minus 8 over 20. And we keep doing this, and we're going to see that the damage we would get from heavy hits is equal to 0.4. We can do this again for brutal hits, and we're seeing that we have 11 minus 8 over 20 times 1. We're only doing one extra damage on a brutal hit, and that's going to be 0.15. And then a critical hit is 2 times 1 over 20. There's just a 1 over 20 chance that we land a critical hit, so that's going to be 0.1 damage from a critical total. So we can add up all these numbers, and we're going to get 1.3 damage as the total damage of a 1 base damage weapon attack using a +4 attack check against a 12 PD, right? So we put all these numbers in together, and we managed to get an answer. So let's kind of make this a little bit more generic now. This would be our equation we'd use if we wanted to put all these things together in some generic situation, right? Let's say you wanted to know with some attack check, some PD, and then some weapon, right, and with some damage, what your damage is going to come out to. Well, that's going to be the weapon damage times our chance to hit, which is 21 plus the attack minus the defense over 20. And then we add on to that the damage we get from heavy hits, which would be 1 times 16 plus the attack minus the defense over 20. And then we add the brutal, which is the same thing as the heavy, except we're using the brutal chance. So there's that 11 instead of the 16. And then we add the critical at the end. So that's 2 more, right, times that 0.05, that 1 over 20 chance that we actually get that 20. Okay. There's a little bit of nuance to this, right, as you're playing around with it. Some situations, like impact, for example. Impact is not going to have this 1 damage from a heavy hit because impact weapons deal an additional damage on a heavy hit. So that 1 damage would have to be replaced with 2 instead. And so we can see that we can play around with this equation a little bit, right? Some features in the game even allow for more damage on brutal hits. So in that case, you would add a 2 there for the brutal instead of a 1. And you can mess around with this a little bit for different situations. Keep in mind that things that are going to buff your base damage, right? Things like rage or a rogue's cheap shot are pretty much the same as just increasing the damage of the weapon. So we can just tie that into that W, right? That base damage of the weapon I have presented. Okay. What about half on miss though? So let's go back to thinking about a spell check example, right? With most spells in the game or any MP effect, there's going to be a half on miss, meaning if you miss the attack, you're still going to do half the damage. Except if you roll a 1. If you roll a 1, the spell fizzles and nothing happens at all. So you can see laid out here at the bottom, I'm using a 2 base damage spell so that we can very clearly see the difference in damages. If you have a 1 base damage spell, DC20 always rounds up, which means if you miss a 1 base damage spell, it's still just going to do 1 damage. So not that big of a difference. So in this case, we can see that on a 1, we get 0 damage. On a 2 to a 7, we get 1 damage. From an 8 to a 12, we get 2 damage. And the same thing moving on from last time. It's just 1 more damage in each category, and then a crit would deal 2 more than it's supposed to. Okay. So we can kind of apply some of the same ideas from before, except this is going to be a little bit more complicated. So here's the half on miss math. We can see we're using the same assumptions from the last slide. And let's talk first about the miss chance. So the miss chance is almost just the opposite of the chance that you hit, right? Anytime you don't hit, you miss. Except if you roll a 1. If you roll a 1, it is technically a miss, but it's not going to be a miss that does damage. So what we can do here is we can take 0.95, basically the chance that you roll anything that isn't a 1, and remove from that the chance that you hit. So now you've basically said, okay, well, I have all these scenarios where I'm rolling something on the dice, and I'm just going to remove from that those scenarios where I actually hit. And what I'm left over with is the chance that I missed. So this is my miss chance. And I'm going to take that and multiply it to the damage, in this case half of the damage, and that's going to give me the miss damage. We can see here if we run the math on these numbers, again, don't feel bad using calculators, that's what they're there for, we would get 0.3. And we could add that damage back to our 1.3 from before. If we were using a 1 base damage weapon, this would still be the miss damage because half of the damage would still be 1, right? Okay. So here's our generic formula. We can see that we're using similar values as before. I'm still using the letter W here, even though this is normally going to be with a spell and not a weapon. I didn't want to change around the values we're using too much. So I'm still using A, D, and W here so that I'm keeping stuff the same. So we were going to have our miss damage be the damage divided by 2. We round that part up before we multiply it. So if I had 3, it would be 2. Because I'd take 3 divided by 2, I get 1.5. We round that up back to 2. And we multiply that by that miss chance we talked about before. So 0.95 minus 21 plus the attack minus the defense over 20. And that pretty much sums up the basics of doing our attack math in DC20. Now, you'll notice there's still a lot of stuff that I've left out. If you've done a lot of very complex attack math in DC20, you'll notice there's some things I haven't talked about. Things like advantage and disadvantage, PDR, DR, using resistances, and a bunch of weird quirks like that. And I will get into some of those next time. Next time I'll definitely be getting into advantages and disadvantages and modifying some of the formulas we talked about this time, but I want to start out with a basic video, getting people to understand how to do the most basic attack math in DC20 and then build up on it with future videos. As always, thank you so much for watching, and until the next time, have the best time.